Well, hello everybody. It's problem 25 from the Exam 2 study guide. This will be the extra credit one on Exam 2, but in the final we'll have one that will count for real. Notice what I have here is an equation, and it is what we call an irrational equation. That is, it involves ratios, fractions. And I've gone ahead and I've set this thing up, building some elongated fraction bars, and putting everything in parentheses here. And notice too that I did factor out here an x from both of these terms, and that left behind an x plus 2, and I put parentheses around them. And the game here is to collapse the fractions, to clear the fractions. And you can begin anywhere. I'm going to suggest that we begin, well, here at the beginning, at the first term. Wouldn't it be nice if I had an x here? Because if I did, these would cancel and the fraction would be gone. Well, since we have an equation, we have this ability to multiply by x and not change the equation so long as everything takes that multiplication by x. That means the second term has to get multiplied by x and the right hand side has to get multiplied by x. Now I've already canceled here, but notice I can also cancel here. So I'm a step closer to clearing this fraction too. And I'm going to go ahead and talk about the least common denominator as well. Notice I've multiplied everything by x so far. And now what I'll do next is say, well, wouldn't it be nice if I had an x plus 2 here? Because if I did, these would cancel. And notice the fraction would be gone in the second term. And again, because I have an equation, I can do that by multiplying everything by x plus 2, including the original first term, and including the right-hand side. Now, notice that these also cancel, and the fraction vanishes over here. It's gone from here, and it's gone from here. The fraction has completely vanished. Notice I multiplied by everything by x plus 2. And in fact, that is my least common denominator. If I multiplied everything by x times x plus 2, then all the denominators disappear. And so that is the least common denominator. I sort of built it on the fly. Now, I no longer have fractions here. In fact, we're just looking at the top. And what we have here is distribution. So let me go ahead and do that. To get 3x plus 6, I have this addition, and then I have x times x, or x squared. And everything is gone on that right hand side except for that 4. And lo and behold, we have a quadratic equation. The unknown is to the second power, which is our 5.8. Later on in the book, we'll deal with quadratics again. But for now, 5.8 is the only thing we've seen. And the quadratic means we're probably going to have two solutions. And the technique in 5.8 was to write it in descending order. So I'll go ahead and do that. And then it was to get everything on one side and 0 on the other and factor. So I'll subtract 4 from both sides. And 6 plus 6 minus 4 is plus 2. So I have everything is equal to 0. And the game was to crack this, and it does crack. It's not a prime trinomial, and it will be though in later chapters, but here it's not. And so we have a very simple technique for solving. We're looking for two numbers that multiply to plus 2 and add to plus 3. And these two numbers do in fact multiply to plus 2 and do in fact add to plus 3. And so once we find those numbers, we're done. We've cracked the trinomial. And we go into this idea of what makes this 0 or what makes this 0, because we're using what's called the principle of zero products. Something times something to give 0. Well, either this is 0 or this is 0. And so what makes this first linear factor, that's the technical term, what makes this first linear factor 0? And the answer is when x is equal to -1. And what makes this second linear factor 0? And the answer is when x is equal to -2. And so we found the two solutions to this particular quadratic. But remember, we actually began with a rational equation. And there were certain restrictions on that. We can never be dividing by 0, and so I could never let x equal 0 here. That would be a no-no. And I could never let x equal -2 here, because this would be a 0. So there were two restrictions on what x could be, and lo and behold, look, we can't let x be -2. Now it's true, -2 will work in this trinomial, but the original problem was a rational equation that we collapsed into a trinomial. So we do have to exclude this, as it causes the rational equation to try and divide by 0, which is a no-no. So there's only one solution. X is equal to -1. So that's the problem, and that's the solution. I hope that helps, and good luck on the exam.